Hey everybody, I'm back solving some more trigonometric equations. All right, this one is tricky. We've got it looks quadratic, but we have a sine squared and then we have a cosine of theta. And so those don't match up. So my first trick is actually going to be to use one of our trig identities, the Pythagorean identities. And I'm going to change sine squared to cosine squared because I have a cosine already. I can't change a cosine to a sine, but I can change a sine squared to a cosine squared. So sine squared is 1 minus cosine squared theta plus this root 3 cosine theta plus 1 equals 0. And so this is 2 minus 2 cosine squared theta plus root 3 cosine theta plus 1. 2 plus 1 is 3. I'm also going to just multiply this whole equation by -1. The 0 will stay 0, but this negative in front of the 2 cosine theta becomes positive. So we have minus root 3 cosine theta, and then we have a minus 3. And the 3 again came from the 2 and the 1 being added together, but then I multiplied through by a negative. All right, so here we are. This is a quadratic, people. Just like on the last one, we can let x equal cosine theta, and we have 2x squared minus root 3x minus 3 equals 0. Now, I wouldn't be able to factor this one because of the root 3, but I can use the quadratic formula. And the quadratic formula says that x is going to equal negative b plus or minus the square root of b squared. So that's going to be negative root 3 squared minus 4a, that's not a, that's c, a c all over 2a. Now negative root 3 squared is just 3, and then plus 24 we have over here. So 3 plus 24 is 27. So we have root 3 plus or minus the square root of 27 all over 4. 27 can be written as 9 times 3, so I can actually pull out a 3, have it be a 3 root 3, which means that x can equal root 3 plus 3 root 3, which is 4 root 3 over 4, which is root 3, or x can equal root 3 minus 3 root 3, which is negative 2 root 3 over 4, which is negative root 3 over 2. All right, but remember, we're not solving for x, we're solving for theta. So we're really saying we want this to equal cosine of theta and this to equal cosine of theta. Well, cosine of theta cannot equal root 3 because root 3 is bigger than 1. And so this has no solution here. But I can figure out where cosine of theta equals negative root 3 over 2. I feel like I already did that today. So that's going to happen when theta is equal to 5 pi over 6 and when theta equals 7 pi over 6. So the solutions to this problem are both 5 pi over 6, so pi over 6 short of pi, and then pi over 6 past pi. And I think that's what we got in our first problem. I think we had set cosine equal to negative root 3 over 2. So that is between 0 and pi. Those are the only, or 0 and 2 pi, sorry. Those are the only two solutions. So a lot happened in here. First, we made it look like a quadratic so that it was easier to solve. We used the quadratic formula to get these two answers, but that was for x. We wanted to find theta, so we plugged back in cosine theta, and then we used our skills from earlier in the lesson to figure out the solution to this equation. And we didn't have to list all of them, the infinitely many solutions. We just needed the two that were between 0 and 2 pi. All right, let's do one more. So this is the last one. We want to find all the solutions, again, from 0 to 2 pi. We have root 3 cosine x equals sine x plus 1. I want to solve for x. I don't like the fact that we can't turn a cosine into a sine without the cofunction identity, and that just adds more stuff on the inside that I don't want to deal with. I could change a cosine to a cosine squared to a sine squared, but that would mean I'd have to square both sides. So that is something I'm willing to do. Now careful here when you're squaring both sides. On the left side I can square the root 3, so that gives me 3. And I can square cosine, that gives me cosine squared. But on the right side we have two terms, and so I have to make sure that I'm multiplying this out, distributing properly. This is sine x plus 1 times sine x plus 1, which gives me sine squared x plus 2 sine x plus 1. Now I can definitely turn this cosine squared into a sine squared by doing 1 minus sine squared. That's the Pythagorean identity. Now I should warn you at this point, since we did square both sides of the equation, this is an extraneous solution alert. Anytime you square both sides of an equation, you need to be mindful that you might have created some solutions that aren't actually there. Because as soon as I square both sides of the equation, if I had something that made one side negative and the other side positive, but the same value, and I square it, now they're both the same positive value. And so I might have created solutions that aren't really there. But we're going to continue to solve this, and we can check at the end to see if all of the solutions we get work. So this is 3 minus 3 sine squared x, just distributing here, equals sine squared x plus 2 sine x plus 1. Let's get everything on one side. If I add 3 sine squared x, I'm going to get 4 sine squared x plus 2 sine x, and then I'm subtracting this 3, so minus 2 equals 0. Did I do that right? Subtract 3 from 1 and I get minus 2, right? All right, so can we factor this? Well, we can if we divide both sides by 2. I think that'll make it easier. So let's divide both sides by 2. Okay. That makes things a little bit easier. So I know if you want, at this point, you could let theta equal sine x, and then it might be easier for you to look at it that way. I know the only way I'm going to get 2 something squared is by having 2 of something times that something, and then the only way to get a negative 1 is a negative 1 and a positive 1. Since this comes out positive, I definitely want the positive to go with the 2 to make this bigger. So this is how it factors. So that means that sine of x equals 1/2. That comes from this, setting that equal to 0. And we know that sine of x equals negative 1. And that comes from setting this equal to 0. All right, so this one I'm going to start with. Sine equals -1 when x is 3 pi over 2. And sine equals 1/2. We've seen this on almost every problem at pi over 6 and 5 pi over 6. Okay, so let's, these are the 3 possible answers that we're going to get. Let's check them all. Okay, so I'm going to plug it back into the original. So the original equation, let me write it down here just so that we're on the same page. We have the square root of 3 cosine of x equals sine of x plus 1. So let's start with pi over 6. Okay. When I plug pi over 6, I get root 3 times cosine of pi over 6. And that's going to equal sine of pi over 6. It's going to equal sine of pi over 6 plus 1. Okay. Cosine of pi over 6. Anyone? So we're not as far up as we are to the right, so we're farther to the right. So this is root 3 over 2. So this gives me 3/2. And on the right side here, sine is not as big, so that's the 1/2. Plus 1 gives me 3/2. Ta-da! So pi over 6 works. So let's start our solution set over here. Pi over 6. Right, let's check 5 pi over 6. Okay. So root 3 cosine of 5 pi over 6 equals sine of 5 pi over 6 plus 1. So cosine of 5 pi over 6 is still root 3 over 2. So this gives me 3/2. Sine of 5 pi over 6. Now we're in the second quadrant. Oh, wait. This is negative 3/2. Second quadrant, sine is still positive. So this comes out to 3/2, which is not equal to 3/2. So this one doesn't work. 5 pi over 6 is not a solution. And now let's try 3 pi over 2. So root 3 cosine of 3 pi over 2 equals sine of 3 pi over 2 plus 1. Well, sine of 3 pi over 2 is -1, so this comes out to 0. And cosine of 3 pi over 2, well, that's 0. So that works as well. So we have, oh, not 0. So 3 pi over 2 works along with pi over 6. We get 0 for both of those. And so these are my 2 solutions to this last problem. Again, we went through a lot here. Watch the video again if you need to. These last 2 problems are definitely taking things up a notch. You're not gonna, I don't think you're gonna see anything this difficult. You might see something that requires a little bit more than what we did on some of the earlier problems, but nothing that's this involved. You might have to square both sides, but the numbers will be easier. It'll probably just be one term on either side. And so just be aware that you might have to do something like this, but it's not going to be this involved. There's just so much going on here. All right. Hopefully I will talk to you all soon.